So up until this point, we have done, like, when the degree is bigger on the numerator, we had to find oblique asymptotes. We had to do that whole long division. Okay. For 6 and 7, what's going to happen is now we're going to have to factor. So we should have been factoring all along, and it's so you're going to have to get in the habit of factoring again, you guys. And what's going to happen is we're going to have stuff that cancels out, and so that's going to affect how we graph. So let's look at example 6. Well, actually, let's look at the key concept right here, and then I can show you. So you're going to find your vertical asymptote just like you normally would, right? You take the denominator, you set it equal to 0, and you find that vertical asymptote. And if it needs to be factored, you factor it, and that's what you do. So you guys, right here, this example, it's already been factored in the numerator, always been factored in the denominator. So our vertical asymptote is x plus 1 equals 0, so x equals -1. But then you'll notice that the x plus 1's cancel out. Do you guys see that in the key concept right here? See how x plus 1 and x plus 1, they cancel out? So what happens to that vertical asymptote is it's no longer a line, but what we call a point of discontinuity. What that means is your graph still goes on, but at that one particular point, it's like a break in the graph, right? It's like you skip over it. So we're going to do number 6 so I can show you exactly what I mean. Again, you guys, you're going to find your vertical asymptote just like you normally do, but if it cancels out in the numerator as well, it's no longer a vertical asymptote, it becomes a point of discontinuity. So let's do number 6. So anytime you see a trinomial in the numerator or you see a trinomial in the denominator, you really need to factor it. So because a is 1, there's a 1 in front of that x squared, we're going to look for two numbers you can multiply to get -5, and when you add them, you get +4. So how do you factor that? What are two numbers you can multiply to get -5, and when you add them, you get +4?
5 and -1.
Okay. So it's going to be x plus 5 and x minus 1. Because 5 times -1 is -5. 5 plus -1 is +4. And then we have x plus 5 on the denominator. Okay, so now we're going to find that vertical asymptote just like we've been doing since Monday. So how do you find the vertical asymptote? Set the denominator to 0. So x plus 5 equals 0. X equals -5. So that's your vertical asymptote. Now that you found that, you factored, you found your vertical asymptote. Now here's my next question. What's my horizontal asymptote? What is the degree of the numerator?
2.
What is the degree of the denominator?
1.
So if it's greater, if the numerator is greater than the denominator, what type of horizontal asymptote do I have? There's none. Okay, so that's good to know. Now here's the other thing. Yesterday, when I said if the degree was 1 more than the denominator, we found an oblique asymptote. But here's the thing. We're going to factor, and now before we find that oblique asymptote, we notice that these cancel out. So what I'm left with is f of x equals x minus 1. So I'm no longer left with a rational expression. I'm left with a line to graph. So what we're going to do is we're going to graph that line, and our vertical asymptote is no longer a line, it's going to be a point of discontinuity. Again, the reason it becomes that is because it cancels out in the numerator and the denominator. So let's try it. So let's get a piece of graph paper and let's, if you're worried, right, you're like, I'm gonna miss my point of discontinuity, like I don't know exactly what that means. Lightly, let's put in your vertical asymptote. My vertical asymptote is x equals -5. So lightly, 1, 2, 3, 4, 5. Let's just put a little line there. Let's not make it too dark. Let's just lightly put it in. Because what's going to happen is I'm going to have to go back and erase it. Because it's not, it shouldn't be there, okay? Because it canceled out in the numerator, it shouldn't be there. It's going to be a point of discontinuity. So let me show you what I mean by that. So let's graph it. So I'm going to graph y, basically y equals x minus 1. So where am I going to start at? Where do I start at?
-1.
-1. And then what am I going to do? I'm going to go, what's my slope? Which is,
1.
so I'm going to go up 1 to the right 1, up 1 to the right 1. And I'm going to go, you guys, on these, you need to go as far as you can. And then you need to go down. Like, you need to make sure everything is there because you need to put your point of discontinuity in. Down, 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 down. And look, see right here? See, I'm about to cross my vertical asymptote. You guys, everything on your, I didn't make my graph big enough, but in your homework, your graph will always be big enough that it's going to show that point of discontinuity. And then I'm just going to connect those dots. And now, when you get to the point of discontinuity, you don't go through it, you guys. You kind of just stop. And then make sure that there are no evidence that you even drew the vertical asymptote. I'll just throw stuff on the floor. So again, you guys, when your vertical asymptote ends up canceling out in the numerator and the denominator, it becomes a point of discontinuity, and you end up drawing a line.